Over the years, I've seen many students go from feeling lost to completely acing their chemistry exams, and I want that for you too. In this video series, I've put together some IB exam review questions, both HL and SL. HL questions will be marked in the video. For more curated interactive lessons, either one-on-one or in small groups, feel free to visit me at onlinechemistrytutorbros.com. See you there. Consider the composition of the species W, X, Y, and Z below. Which species is an anion? In a neutral atom, the number of protons must equal the number of electrons. That way, the charge is balanced. So in each of these species, we can check which ones have an unequal number of protons and electrons. You can cross out Y because they have the same number of protons and electrons. Now the question is, which species is an anion? An anion is a negatively charged species, and a cation is a positively charged species. The number of protons in an atom is always the same. If the number of protons change, then the atom becomes an atom of another element. So since this cannot happen, proton number should always be the same. But the atom can gain or lose electrons, thus creating an imbalance in the number of protons and electrons. Hence, anions are formed when the atom gains extra electrons, and so you have an excess of electrons compared to protons, and so there's an overall negative charge. And cations are formed when electrons are lost, so you have more protons than electrons, and you have an overall positive charge. So we need to compare the number of protons and electrons and check which of these species has the greater number of electrons so that it becomes an anion with an overall negative charge. So there's Y because you have 10 electrons but fewer protons, that's 9. X have equal number of protons and electrons, so cross that out. And Z has 13 protons, more protons than electrons, so that should be a cation, so that you cross that out. So the right choice is A, W. Please note that neutrons are neutral, so their number does not contribute to the charge of the atom. So the number of neutrons does not matter. What is the correct number of each particle in a fluoride ion? F19, negative. If I check the periodic table, I find the atomic number of fluorine to be 9. Atomic number gives you the number of protons, which will also be equal to the number of electrons if the atom is neutral. But we see here that there's a charge, and it's a negative charge. So there's one excess of electrons. So the number of electrons will be equal to the protons plus one extra, and that will be 10 electrons. The mass number is 19. Mass number is the total number of protons and neutrons. So neutron number is just the mass number minus the atomic number. So it's 19 minus 9. That's 10. Hence we have 9 protons, 10 neutrons, and 10 electrons. Choice C. A certain sample of element Z contains 60% of Z69 and 40% of Z71. What is the relative atomic mass of element Z in the sample? The two isotopes of Z are Z69 and Z71. Abundance, if you have 100 atoms of Z, 60 atoms would be Z69 and 70 of it would be of Z71 isotope. The relative atomic mass of the element Z would be the average mass of both isotopes in their relative abundance. Relative atomic mass would be in 100 atoms of Z, 60 atoms of Z would have a mass of 69, and 40 atoms would have a mass of 71. That comes to 69.8. Choice B. What is the difference between two neutral atoms represented by the symbols cobalt 5927 and nickel 5928? We have number of protons down here, and these are the total number of protons and neutrons, or the mass numbers. Since the atoms are neutral, cobalt will have 27 protons and 27 electrons. Nickel has 28 protons and 28 electrons. Neutron number for cobalt is 59 minus 27, and neutron number for nickel is 59 minus 28. So cobalt and nickel have different number of protons, different number of electrons, and different number of neutrons. Hence all three. How many electrons are there in one Mg2412 plus 2 ion? Please pause the video and try this yourself. The proton number is 12. That's equal to its atomic number. And since the charge is plus 2, there are 2 fewer electrons than protons. So 12 minus 2, 10 electrons. Choice A. Information is given about 4 different atoms, W, X, Y, and Z. Neutron numbers and proton numbers are given. Which 2 atoms are isotopes? We know that isotopes must have the same number of protons and so the same atomic number. W and Z have 18 protons, the same number of protons, and they should have different neutrons. 22 and 20 is different. So the isotopes are W and Z. How many neutrons are there in the ion O18, 2 minus? For the number of neutrons, the charge does not matter. Charge is important only when counting the number of electrons. For number of neutrons is mass number minus the atomic number. That's this minus the number down here from the periodic table for oxygen is 8. That's 18 minus 8, 10 neutrons. Choice B. There are 2 questions here. Please pause the video and try these yourself. I'm leaving the answer choices here. What is the symbol for a species that contain 15 protons, 16 neutrons, and 18 electrons? Since the number of protons is 15, the atomic number will be 15. So we can cross out the ones whose atomic number is not 15. Choices C and D has 15 protons. Now we compare the number of electrons. You have 18 electrons here. That's 3 more than the number of protons. So 3 excess electrons means there would be an excess of 3 negative charge. So the right choice is D. Which species has 54 electrons and 52 protons? So again, 52 protons means atomic number must be 52. So you can rule out choices B and C. And 54 electrons is 2 more than the number of electrons, 2 negative charge, A. Here are a few questions you could try yourself. Atomic number of nitrogen is 7, sulfur 16, iron 26. You can get these from the periodic table. We are moving to paper 2 style questions. The element vanadium has 2 isotopes, vanadium 50 and vanadium 51, and a relative atomic mass of 50.94. Define the term isotope. So atoms of the same element that have the same number of protons but different number of neutrons. Because they have the same number of protons, they have the same atomic number. And because they have different neutrons, they have different mass numbers. State the number of protons, electrons, and neutrons in vanadium 50. Protons 23, electrons 23 because it's neutral, and neutrons is 50 minus 23. State and explain which is the most abundant isotope. Since the relative atomic mass is 50.94,
And that's the weighted average mass of both isotopes. This is almost equal to 51. It's closer to the mass of vanadium-51 isotope. Hence, vanadium-51 is the more abundant isotope. State the name of and the mass number of the isotope relative to which all atomic masses are measured. So carbon-12 isotope is taken as a standard, and the relative atomic masses and molecular masses are weighed relative to the carbon-12, assuming that this carbon isotope has a mass of exactly 12 units. And so 1/12 the mass of a carbon-12 isotope is taken as exactly one relative atomic mass unit. A sample of argon exists as a mixture of three isotopes, mass number 36, 38, and argon 40. Calculate the relative atomic mass of argon given these percent abundance. In 100 atoms of argon, 0.337 has a mass of 36, 0.063 mass of 38, and 99.6 with a mass of 40. State a physical property that is different for isotopes of an element. Since isotopes differ only in masses and they're atoms of the same element, physical property like mass or any physical property that depends on mass like density, since density is mass over volume, would be different for the isotopes. And in case of gases, the rate of diffusion or effusion of gases depends on the mass of the gas. The heavier isotopic gas would effuse or diffuse at a slower rate than the lighter isotope. Since for gases, the only type of intermolecular force is the London dispersion force, and heavier molecules would have higher melting and boiling point, the heavier gaseous isotope would have the greater melting and boiling point than the lighter one. Chlorine exists as two isotopes, chlorine 35 and 37. The relative atomic mass of chlorine is 35.45. Find the percent abundance of each isotope. This is a slightly different problem. Usually you would be given the percent abundance and you have to find the relative atomic mass. Here the relative atomic mass is given, and if it's not given, you can look at the periodic table and get it if you need to find the percent abundance. So in this case, let's take the percent abundance of one of the chlorine as X and set the other as the remaining 100 minus X percent. And we set this up in the usual equation. Relative atomic mass is equal to, in 100 atoms, 35 atoms have an abundance of X, and 37 atoms have an abundance of 100 minus X, and then solve. So X was set as the percent abundance of chlorine 35. So chlorine 35 would have an abundance of 77.5%, and chlorine 37, the remaining 100 minus 77.5%, that's 22.5%. Here is another question for you to pause and try. I'm sure by now you will get this. And that's the end of practice for structure 1.2, the nuclear atom.